Choosing which data set to analyze, we wanted one that was interesting to the entire group. The US and Mexico border has been one of the most important political topics in the last decade. It's a divisive issue that everyone has a different opinion on. For many Americans, it was the single most important factor when choosing a candidate in this year's election. With all of that being said, we thought it would be interesting and helpful to analyze how, where, and when many of these border crossings happen to educate not just ourselves, but others as well. Our project focuses on analyzing U.S. border crossing data, specifically entries along the U.S.-Mexico border. This data set contains over 355,000 records detailing crossings by port name, state, port code, border type, date, transportation mode, and entry count. Given its comprehensive nature, this data set is valuable for understanding and predicting border traffic trends. We chose to focus on the measure and value columns, limiting our analysis to the US-Mexico border and transportation modes with the highest counts. This approach allows us to identify key traffic patterns efficiently. Our research questions explore how passenger counts vary by transportation mode, such as personal vehicles, buses, and pedestrians. We also examine trends in personal vehicle passenger counts over time. These questions are crucial because they reveal not only current traffic patterns, but also future changes in border crossing dynamics. Our dataset focuses on key variables from the US-Mexico and US-Canada border crossing dataset. These include port name identifying specific entry points and state indicating where crossings occurred. The port code assigns a numerical identifier to each point, while date records when entries happened. We can also see a variable measure, which describes the type of crossing, such as personal vehicles, buses, or pedestrians, and value, showing the numerical count for each type. By analyzing these variables, we can uncover important trends in border traffic and transportation patterns over time.
For the pre-cleaning, the bar chart displays the total number of border crossings for each transportation type, referred to as measure, along the US-Mexico border and US-Canada border. The x-axis shows the total value representing the cumulative number of crossings, while the y-axis lists different crossing types, such as personal vehicles, buses, pedestrians, and trucks. Each bar's length indicates the total number of entries for that specific transportation mode, with distinct colors assigned to each measure for clarity. The chart likely reveals that some modes, such as personal vehicles or pedestrians, have significantly higher counts compared to others like buses or commercial trucks, reflecting differences in transportation usage patterns at the border. This visualization helps to identify which modes contribute the most to border traffic. The tidy dataset. To ensure accurate and meaningful analysis, we cleaned key variables in our dataset. First, we replaced any missing values, NA, with 0 to avoid calculation errors. Next, we renamed columns for clarity, for example, changing port name to port and measure to mode transportation, making the dataset easier to interpret. We removed the port code column since it wasn't directly relevant to our research questions. Then we filtered the dataset to include only the US-Mexico border entries, focusing on the area of interest. Finally, we converted the date column to a date format, allowing for proper time series analysis. These steps helped streamline our dataset, ensuring our analysis would be accurate, relevant, and easy to understand. For the linear regression model code, we chose the linear regression model to analyze the trend of personal vehicle passengers crossing the US-Mexico border over time. By filtering for personal vehicle passengers and extracting the year from the date, we can examine how crossing counts have changed annually. The scatter plot with the regression line provides a clear visualization of the trends, while the blue line helps highlight whether there's an upward or downward shift in passenger counts. Additionally, we faceted the plot by state to see regional differences. This model helps us understand the broader trend and identify any notable patterns or shifts in passenger traffic over the years, providing valuable insights for future planning and predictions.
We began by exploring the distribution of border crossings across various modes of transportation. Specifically, we wanted to see how different transportation types, such as personal vehicle passengers, buses, and pedestrians, were distributed across the US-Mexico border by state. For this, we used a simple bar chart to visualize these counts. This chart helped us identify how much each state is contributing to the overall traffic for different transportation modes. Why did we choose this approach? This type of visualization allows us to quickly spot trends and regional variations in the data. showing us where high volumes of specific transportation modes occur. This valuable for policy and resource allocation decisions. Knowing which states or modes require more focus can help authorities improve border management. Next, we zoomed in on the three modes of transportation with the highest counts: personal vehicle passengers, pedestrians, and bus passengers. We created a bar chart to compare how these modes of transportation performed across states. This visualization allows us to view separate plots for each state, providing insight into the distributions of the three most common modes of transportation. By faceting the plot by state, we could observe patterns within individual states. For example, we saw that personal vehicle passengers traffic is most prominent in states like California and Texas. Why did we choose to focus on these three modes? These modes represent the highest traffic volumes, and understanding them helps identify where the majority of crossing activity happens. This analysis is critical for understanding which modes of transportation need the most attention when it comes to infrastructure, security, and border management. To deepen our understanding, we turn to a multiple regression model to analyze the relationship between the year, mode of transportation, and passenger count. This allows us to evaluate how passenger counts have evolved over time for different modes of transportation. This regression model uses year and mode of transportation to predict count. By fitting this model, we can understand how the passenger counts for each transportation mode have changed year over year. The model revealed that, for example, personal vehicle passengers showed an upward trend, while pedestrian traffic remained relatively stable. Bus passenger traffic, however, fluctuated more significantly. Why did we choose a multiple regression? The regression model allows us to quantify how different factors, time and mode, contribute to the total count of passengers. It helps isolate trends and patterns that real-world data can mask. After building the regression model, we wanted to visualize the predicted values versus the actual values to see how well our model fits the data. We did this by plotting the predicted values for a regression model alongside the actual counts. This plot shows the actual data points and predicted values for each mode of transportation. Provides a clear visual comparison highlighting how well our model is predicting passenger counts. If the line closely matches the points, it indicates a good fit. Any deviations show where our model might not capture certain variations in the data. Why did we choose this approach? Visualizing the predicted versus actual values allows us to assess the model's performance and pinpoint where it may need improvement. This type of visualization is crucial for validating our analysis and ensuring that our conclusions are based on reliable predictions.
In our analysis, we initially explored both a random forest model and a decision tree to model for identifying patterns in the U.S.-Mexico border crossings. However, the results from both models were not sufficiently robust to be included in our final analysis. The random forest model, for instance, produced an out-of-bag error rate that was in the hundreds of thousands, indicating poor performance and suggesting that the model was not capturing the underlying relationships within the dataset effectively. Similarly, the decision tree model failed to provide meaningful insights required for a thorough understanding of the border crossings patterns. Given these challenges, we opted to use a multiple linear regression model, which provided a more appropriate and interpretable approach to analyzing the data. Over the years, the number of personal vehicle passengers crossings in the U.S.-Mexico border has steadily declined from 1996 to 2020. This trend can be attributed to a combination of various factors, including changes in immigration patterns, stricter border policies, economic shifts, and an increasing reliance on alternative forms of transportation. One key factor contributing to the decrease in the heightened security is the heightened security measures that were implemented after the 9/11 attacks. These measures made travel more difficult and likely discouraged some individuals from crossing the border by car. Moreover, the fluctuating economic conditions in both the U.S. and Mexico countries have had an impact on the volume of cross-border travel. Economic downturns, rising fuel prices, and other financial factors may have reduced the need for people to make trips across the border. Over time, people may have chosen other modes of transportation, such as air travel or even virtual communication, instead of crossing the border in personal vehicles. Additionally, political factors have played a role in this decline. The U.S.-Mexico border has increasingly become a central issue in political debates, particularly in discussions surrounding immigration policy and border security. Over the years, discussions around immigration reform, stricter enforcement measures, and efforts to control illegal crossings have led to heightened tensions and restrictions at the border. These debates have made the border a focal point of the U.S. political discourse, especially during election cycles. Overall, the decrease in passenger numbers at the border is the result of complex interaction of social, political, and economic factors. Changes in the political climate, economic pressures, and shifting patterns of immigration and travel have all contributed to the overall decline in personal vehicle crossings at the U.S.-Mexico border over the past few decades.